Antiderivatives and indefinite integrals. An antiderivative of a function f of x is a function whose derivative is equal to f of x. That is, if f prime of x is equal to f of x for all x in interval I, then f of x is an antiderivative of f of x. So if you look at the illustration, you have 2x. The antiderivative of 2x is x squared because the derivative of x squared is 2x. Consider the following functions. We have y equals x squared plus 3, y equals x squared plus 1, and x squared minus 2. If you get the derivatives of these functions, we have y prime equals 2x. When we get the antiderivative of 2x, we get a family of curves in the form of x squared plus c, which is our general solution. The operation of finding all solutions of a differential equation is called antidifferentiation or indefinite integration. Here we have the notation of antiderivatives. We have the integral sign, the integrand, variable integration, constant of integration. The expression is read as the antiderivative of function with respect to x. Here we have the basic integration rules. Example for basic integration rules. We have the antiderivative of 3 dx. We get 3x plus c. Another example, we get, let out 5, then we have x dx. 5 times x 1 plus 1 over 1 plus 1 plus c. So we'll have 5 x squared over 2 plus c. So we'll have 5 x squared over 2 plus c as our final answer. Next example, sometimes when you get antiderivative of a function, you have to rewrite it before you can start integrating. Here, let's try to rewrite 1 over x cubed dx, x to the negative 3 dx, x to the negative 3 plus 1 over negative 3 plus 1 plus constant, x to the negative 2 over negative 2 plus c. So simplifying our answer, we get 1 over 2x squared negative plus c. Another example, we rewrite this one. So we'll have x to the 1/2 dx, x 1/2 plus 1 over 1/2 plus 1. Then we have x 3 over 2 over 3 over 2 plus c. So simplifying, 2/3 of x to the 3/2 plus c. Example, antiderivative of 2 sine x dx. So let out 2 sine x dx. Then we have 2 antiderivative of sine x, which is negative cos x, plus c. So multiply, you have negative 2 cos x plus c. Next example, we have the antiderivative of x plus 2. So we get antiderivative of x dx plus antiderivative of 2 dx. So we'll have x squared over 2 plus c sub 1 plus 2x plus c sub 2. Simplifying, we'll have x squared over 2 plus 2x plus c. Note that c sub 1 plus c sub 2 is equal to c, because constant plus constant is just the same constant. So we have here integrating a polynomial function, 3 times x4 plus 1 over 4 plus 1 minus 5 x2 plus 1 over 2 plus 1 plus x1 plus 1 over 1 plus 1 plus c. Then we have 3x to the 5th power over 5 minus 5x cubed over 3 plus x squared over 2 plus c. And that's it. Next, we have here, before we can integrate, take note that it is not correct to say that integration of x plus 1 over the integration of square root of x dx. So this is not correct. So we still have to rewrite the function in order to get the antiderivative. So when we rewrite, we'll have x over square root of x plus 1 over square root of x dx. This is a property of a fraction with the same denominator. X to the negative 1/2 plus x to the negative 1/2 dx. So we'll have antiderivative of x to the 1/2 plus x to the negative 1/2. Then we have x to the 1/2 plus 1 over 1/2 plus 1 plus x to the negative 1/2 plus 1 over negative 1/2 plus 1 plus constant. So simplify, x 3 over 2 over 3 over 2 plus x to the 1/2 over 1/2 plus c. Simplifying, you have 2 x 3 over 2 over 3 plus 2x to the 1/2 plus c. This is now your final answer. Rewriting this one, we have sine x over cos x times cos x dx. So we have 1 over cos x times sine x over cos x dx. So we'll get secant x tangent x dx. So that will give us a sec x plus c as our antiderivative. And that's the end of the presentation.